uh, wondering fairly often, is this sort of lecture needed? But looking at the code that I see among third-year students and fourth-year students, you folks need this early, you need it often. So prove me wrong. I'd love to be proven wrong. I'd love to see some beautiful code, starting with assignment 1. Actually, start with 1. Look forward to looking at it. Please don't show me something more similar to binary search than showing me a lot of BS. Okay, okay, so let's talk about macros. How many people here have made use of C's macros before? Who can tell me what a macro is in C? Okay, it provides a very easy sort of shortcut mechanism for doing what? Well, we can define a function as sort of a macro. It's not actually a function. It's a macro that is like a function in the sense that it substitutes an expression. And really what macros do is they're substitutions. They're a quick name for a substitution. And it allows us to give that nickname, and it gets expanded, substituted the full value. It's kind of like an alias on the shell, except macros are used in C code. C code or C++ code. And we'll see some examples of this, but one example might be you have pound define. So this is how you declare, most common way to declare a macro. And you could have pound define, for example, row count, row underbar count to be a value of, say, 10,000. And then, instead of littering your code with 10,000, you use row count throughout your code. Chances are they appear many, many times. And what's one advantage of that? Yeah, you change it in one place, here, and changes throughout the code. So that's kind of nice, it's convenient. What's another advantage? Yes. It's a lot easier to make sense of this, what it really means, what it's getting at, what the intention is, than to look at all these scattered around 10,000s. And this is the point I'm going to come back to later. What's especially easier is to look at something like row underbar count divided by 2, or row underbar count minus 1. These things are much easier to understand than if we just saw 5,000 in our code or 9999. Why could this be important, to be able to kind of look at this expression rather than just look at 5,000? Just a number? We know the meaning. And what that means is, among other things, if we were to go change row count, this gets automatically updated, right? Suppose we were to change row count, suppose we were to conceptually, want to change it from 10,000 to 20,000. If we aren't doing something like this where we symbolically say row count divided by 2, if we just have 5,000 in some places, 9999 in other cases, then we've got a heck of a job in front of us. Because we need to not only change every time 10,000 appears in the program, make it be 20,000 instead, just search and replace. That's trivial. But dangerous, trivial. Dangerous because maybe there's some 10,000s that are the column count or something like that. But we might aspire to that. That's more straightforward. But now we've got to find all these other cases, things like 5,000 or 9999, which are conceptually dependent on row count, but it's not obvious. So if you see 9999, maybe that's row count minus 1 conceptually. Maybe it's column count minus 1. And if that's not, if you don't have an expression that makes that clear, like row count minus 1, you're going to be guessing, should this 9999 be changed or should it not be changed? I want to change row count to 20,000. Do I update this 9999 or do I not? Well, it depends where it comes from. It depends what its meaning is. And ladies and gentlemen, that's much clearer if you provide this row count minus 1 expression like that. Is that clear to people? I hope so, because I see magic numbers up the wazoo in third year with third year code. And I'm looking forward to seeing your code next year. In terms of, so macros are really useful for this reason. But macros are used beyond this. This is one of the biggest uses to encode values. But we can do other things too. What else can you do with a macro? Well, it turns out there's many things you can do with macros. And some you don't want to get into. It may be better to be innocent with them. You can create macros and pasting together other macros and some quite evil things. But another thing that you can do is you can define a function, what's conceptually like a function. You could say, for example, minimum of A comma B, and define it to be an expression if A is less than B, then I give what? A, otherwise say I give B. And I could then go use my code, minimum of X and Y someplace in my code, another place I could do minimum of, of K and 100. And what's going to happen when I use this in my code? This is a macro. What's going to happen? I mentioned before it's about substitution, so anyone want to hazard a guess? So if I put in my code min of K, 100, what gets substituted? Exactly. So this would expand to what? Can anyone? Yeah, K is less than 100. If so, return K, otherwise return 100. This just gets substituted in. Okay? And that all gets done, ladies and gentlemen, before your code is actually given to the full compiler, before it actually gets turned into something you can run. There's a stage called pre-processing. Pre-processing. That's used to expand macros, and those could be macros associated with constants, or they could be macros associated with these almost function-like things. Okay. Now these expansions are not immediately visible. So, for example, on your system, you can make them visible by using GCC, giving an option to it. GCC, it's up on the screen here. GCC minus EP. If we wanted to do this, for example, I could do GCC minus E. I mean, minus E is useful enough for most cases, and I could go look at it, and it's actually gone and expanded all the macros. So I had a pound include stdio.h, and now it's expanded it. In that pre-processing, it's expanding pound includes are expanded, and what I mean is that by that is it goes and fetches the contents and sticks them in your program, and pound defines are also expanded. Okay. So this pre-processing stage goes on, and if you run GCC minus E, you can actually see what comes out of that. If you don't, it's going on behind the scenes. You don't know exactly what it is. Okay. Now this gets kind of complicated because some macros, one macro may depend on another, for example. And it turns out that there's some complications because it's simply a substitution concerning precedence. And we'll talk about this. Ladies and gentlemen, Macros, I know you haven't seen them much. I know few of you have used them. If you are to work professionally in C and C++, you will be using macros in quite possibly in a big way. It's absolutely essential to understand how they work. Okay? So they are expansions. They're textual expansions. These are textual rewriting functionality. In other words, wherever it sees row count, it just substitutes what's ever here. Wherever it sees min of A comma B, it just substitutes what's here in the expression, substituting for A and for B. It's simplistic. It's a textual substitution. It actually puts in whatever appeared there. And it does so without paying particular attention. So for example, let me show you some dangers here that can come from this, okay? So here we have min. You may have wondered why did I put all those extra parentheses in here. In fact, I should put more. I should put parentheses around A and B to be really consistent and careful. So why do I do that? Well, suppose we say define how to define min of A and B to be to that expression up there. Great. So we have this this expression there. Now if I have min of x plus plus and y, what does it expand to? Well, it expands to something like above. Oh, it's just a textual expansion, just substituting in the appropriate way. So now, why could this be confusing? Why could this throw someone off?
Increment x twice.
Yeah, this actually could be incrementing x twice. Was that what you meant? No, but it's doing what you said, given that min is defined as macro. What's really dangerous here, what's insidious, what is worrisome, is that when you're using this, you may not know whether min is a macro or whether it's a call to a function. Suppose I implemented min as a function. Suppose I define, int min or int a comma int b, and I had return of that expression. How would it be different? Well, this increment would occur before the function call once, and then it would just pass the value. Maybe x is 2, and it does x plus plus, the value of x gets updated to 3, but it actually uses the value 2 to perform the call. If min is a function. If min is a macro, it just substitutes whatever there. And this could lead, in the case that x is less than y, it could lead to x being incremented twice. Bad news. That's not what you intended, and that's caused, I don't know how many bugs in C programs. And maybe one of the many reasons programs have crashed on you in the course of your lives is because of something as silly as that. Now, that's one concern, the correctness concern, and that's the deepest sort of concern. There's another correctness concern shown at the bottom. I should have organized these correctly. So what's the concern here? So I have min of x and y times 100. If min is just defined in this way up there, why is this a problem? Min of x and y times 100. Whoops. Sorry? This in brackets. What did I mean when I put min of x and y times 100? What was my intention? Yeah. So whichever is the minimum of x and y, give me that, and then multiply that minimum 1 times 100, right? What does this actually mean here on the right-hand side? Okay, so if, excuse me, this should actually be x one. Let me go correct that, so I don't want to confuse people, because it says A and B here. When it gets expanded, A gets, the A up here, gets whatever the first argument it gets substituted in. Whatever's the second argument gets substituted in for B. So this would be this, and why is that a problem? Yeah, well, okay. So if A is less than y, if x is less than y, it's going to return x. Well, if y is less than x, it's going to be returning y times 100. Which is not what you intended, but it's what you told it. Once you consider the macro. That's right. You might do testing of this. Oh yeah, it looks right, and then you don't discover this violation of what you're assuming. So this is a real problem here. And to be clear that these are correctness issues, I just want to link them together. By a correctness issue, I mean they could cause your program to have a bug, to be simply wrong. This last issue with pi of 1,000, imagine pi is something that computes pi. I would have given it a better name, but it's not space here. It's a bit like Fairmont. So if I have pi here, and this call to a function which computes pi to 1,000 digits. Now the minimum of the 1,000th digit of pi and y, what does that expand to? Why could this be a concern, the fact that it expands to this? Twice. Exactly. It's going to go and just do it again. Why? Because it's, ladies and gentlemen, it's just substituting in textually identity. Ladies and gentlemen, macros are extremely common. I can't express. If you go look at code bases for Linux or other things, you'll find just huge amounts of uses of macros. But if you're going to use them, you got to use them with caution. You got to use them in a way that will protect yourself against this. And what is the way of, what's a good way, reliable way of protecting yourself against this? I'm not saying don't use macros. I'm saying use them in caution. What would be the caution here? Okay, but what concrete thing could I do to sort of make this less vulnerable to many of these things? Yeah, so I could put in something like that. And that would help. It would certainly help this case where we have this times 100. Does it help this first case? No. So what's the answer? Well, ladies and gentlemen, among professional software development teams, the answer is you ban it. You're not allowed to use side effects, in other words, things like plus plus, call to a thing which says display or something like that inside a macro, something that's a macro. And that's a big pain because it requires you to know, is min a macro or is it a function? It depends. And it turns out that that's just the rule. Don't put side effects in something that could be a macro expansion. Just being cautious, being careful in what you do. So you rule that out, and you rule this out. If it's something that could be macro expanded, you don't do something which requires a heck of a lot of work because it may be copied many times. And a professional software developer in C, when they're using something like min, they'll be aware this can get expanded. It's just a simple substitution, and therefore, I won't do a long computation in it. So with these two, to ban them effectively, you got to know, is this a macro? And that's painful because this may be code written by someone else. It's not code that you wrote yourself. It's code that someone else wrote. It's a min code, and you're just using it. And now you've got to kind of know, did they use a macro or as a function? But this is such is life in the world of C. Such is life. That's something we need to be careful about, like many things, pointers. On the other hand, something like this, it does protect the inputs. By putting these parentheses in it, it prevents this thing where outside of this, there's something of so-called higher precedence that will now be combined with B. So we can actually prevent some logical problems. And as was noted earlier, this is kind of a particularly insidious one because it may seem correct, but it's actually off base. Does that make sense to people? So if you're using macros, so I tried to give compelling reasons you might want to use macros, particularly for constants. They're often the least bad option that you have. And they make it a lot clearer when you look at things like row count -1 rather than look at 9999. Just a lot clearer, it makes it really easy to use constants. However, if you're going to use macros, particularly for substituting expressions in, where it's almost, you treat it like a function, then you gotta be careful. You can cut off your arm with that buzz saw pretty easily, okay? So, those are some comments on macros here, okay? So let me stop that.